So in question number 8, you're going to be matching each picture, which is the graphs on the right-hand side at the top, to an equation on the left-hand side, and an asymptote, which is listed down at the bottom. The one thing that you might want to think about is how to distinguish these graphs in meaningful ways, because all of the equations look really similar. They all seem to have a very similar looking y-intercept, very similar looking multipliers, and even in some cases similar looking locator points. So it will be helpful to think about this just so you can think about it efficiently as a series of things for which you'll focus on the differences, not the similarities. For instance, if you watched the previous video and noticed my observation about asymptotes, this might be something powerful that can help you match up all the asymptotes relatively quickly. We noticed that the k-coordinate of each graph or each equation is the equation or the number in the equation of the asymptote. So if this one has a positive 2 for its k-coordinate, it's definitely going to have an asymptote of y equals 2. We made that observation before. So I can be certain then, without even graphing letter A, that asymptote V, or y equals 2, is definitely going to match it. Now, you can definitely make that observation for other ones as well. +1, +1, -1, -1. So that asymptote part might want to be the first thing you do, just to make life a little bit simpler. Once you know that the asymptotes are there, that also might help dictate what you're looking at on a graph, because if you know where the flattening is supposed to occur, perhaps that'll help you narrow down which graph you're going to look at. For example, I'm looking for this equation to flatten at y equals 2. So like letter J wouldn't work because that's -2. Ooh, K looks like it's a possibility. That one's flattening in the right spot. L flattens at 1, so no. N flattens at -1, no. N flattens at 1, so no. P flattens at at 2 as well. So K and P look like they're my only two possibilities. Let's delve a little bit deeper. We know that the locator point of this graph is always dictated by the H and the K. So +1 and then 2. So of these two choices, I'm going to look +1 and 2. That is the locator point of letter K. +1, 2. Ooh, that's also the locator point of letter P. So that didn't help me narrow it down too much. But again, any helpful information is good because narrowing is usually the easiest way to make a match. So now let's see what else I can think about. I can think about something like the y-intercept. The y-intercept is always the number in the front of the equation, so -4. If I think about my locator point, that means that the -4 should be 4 units down from the locator. Ooh, in letter K, that's not the case. That's 4 units up. So it must be letter P. 4 units down from the locator point must be here. So I can conclude it must be graph P, because that's the only one that has the locator point in the right place. It has the asymptote flattening where it's supposed to, and it has the y-intercept in the correct place in relation to the locator. So once you've kind of figured out which things match which, then try to use as much common sense to narrow down possibilities in whatever order makes sense to you. Obviously, by the time you do a couple, you don't have as many possibilities left to match. And since there are 1, 2, 3, 4, 5, 6 equations and 1, 2, 3, 4, 5, 6 graphs, you can probably infer that once you've used one of the graphs, it's not going to get used again. So I know that P is done, and now I don't have to worry about it as a possibility for other possible answers. Now, the asymptotes, it does say it's not 1-to-1. It says some of these could be used more than once, and some of these not at all. So I'm not going to cross anything out on the bottom section, even though I did use one of them already, just in case there are other graphs where that +2 might end up being another possibility. And I can already see what it is. So think about what you know, think about how to match things up, and hopefully you can use a little bit of logic and common sense to make all of those matches happen.